Well, welcome to the Red Hat Summit. This is our 14th annual event, and I have to say, looking out over this audience, wow. It's great to see so many people here joining us. This is by far our largest summit to date. Not only did we blow through the numbers we've had in the past, we blew through our own expectations this year. So I know we have a pretty packed house, and I know people are still coming in, so it's great to see so many people here. It's great to see so many familiar faces when I had a chance to walk around earlier, and it's great to see so many new people here joining us for the first time. I think the record attendance is an indication that more and more enterprises around the world are seeing the power of open source to help them with their challenges that they're facing due to the digital transformation that all of enterprises around the world are going through. The theme for the summit this year is Ideas Worth Exploring. And we intentionally chose that because as much as we are all going through this digital disruption and the challenges associated with it, one thing I think is becoming clear: no one person and certainly no one company has the answers to these challenges, right? This isn't a problem where you can go buy a solution. This is a set of capabilities that we all need to build. It's a set of cultural changes that we all need to go through. And that's going to require the best ideas coming from so many different places. So we're not here saying we have the answers. We're trying to convene the conversation, right? We want to serve as a catalyst, bringing great minds together to share ideas so we all walk out of here at the end of the week a little wiser than when we first came here. We do have an amazing agenda for you. We have over 7,000 attendees. We may be pushing 8,000 by the time we got through this morning. We have 36 keynote speakers, and we have 125 breakout sessions. And I have to throw in one plug. Scheduling 325 breakout sessions is actually pretty difficult. And so we use the Red Hat Business Optimizer, which is an AI constraint solver that's new in the Red Hat Decision Manager to help us plan the summit. Because we have individuals who have a clustered set of interests, and we want to make sure that when we schedule the breakout sessions, we do it in a way that we don't have overlapping sessions that are really important to the same individual. So we tried to use this tool and what we understand about people's interests in history of what they've wanted to do to try to make sure that we spaced out different times for things of similar interest for similar people, as well as, and for people who stood in the back of breakouts before, and I know I've done that too, we've also used it to try to optimize room size. So hopefully we'll do our best to make sure that we've appropriately sized the spaces for those as well. So it's really a phenomenal tool, and I know it's helped us a lot this year. In addition to the 325 breakouts, we have a lot of our customers on stage during the main sessions. And so you'll see demos, you'll hear from partners, you'll hear stories from so many of our customers, not on our point of view of how to use these technologies, but their point of views of how they actually are using these technologies to solve their problems. And you'll hear over and over again from those keynotes that it's not just about the technology. It's about how people are changing, how people are working to innovate to solve those problems. And while we're on the subject of people, I'd like to take a moment to recognize the Red Hat Certified Professional of the Year. This is an award we do every year. I love this award because it truly recognizes an individual for outstanding innovation, for outstanding ideas, for truly standing out in how they're able to help their organization with Red Hat technologies. Red Hat certifications help system administrators, application developers, IT architects to further their careers and help their organizations by being able to advance their skills and knowledge of Red Hat products. And this year's winner really, truly is a great example about how their curiosity has helped push the limits of what's possible with technology. Let's hear a little more about this year's winner.
When I was studying at the university, I had computer science as one of my subjects, and that's what created the passion from the very beginning. There were quite a few institutions around my university who were offering Red Hat Enterprise Linux as a course. and a certification path through to become an administrator. Red Hat Learning Subscription has offered me a lot more than any other trainings that I've done so far. That gave me exposure to so many products under Red Hat technologies that I wasn't even aware of. I started to think about the better ways of how these learnings can be put into the real life use cases. And we started off with a discussion with my manager saying, I have to try this product and I really want to see how it really fits in our environment. And that product was Red Hat Virtualization. We went from deploying Rev and then OpenStack and then the OpenShift environment.
We wanted to overcome some of the things that we saw as challenges to the speed and rapidity of releasing code, etc. So it made perfect sense, and we were able to do it in a really short space of time. So, we truly did use it as an innovation lab.
I think idea is everything. Ideas can change the way you see things. An innovation lab was such an idea that popped into my mind one fine day, and it has transformed the way we think as a team. And it's given that playpen to pretty much everyone to go and test their things, investigate, evaluate, do whatever they like in a non-critical, non-production environment.
I recruited Nehas almost 10 years ago now. I could see there was a spark, a potential with her, and she had a real drive, a real passion, and here we are nearly 10 years later.
I'm Nehas. I am a Red Hat certified engineer.
All right. Well, everyone, please welcome to the stage Nehas. Congratulations.
Thank you.
I think that took. Well, welcome to the Red Hat Summit. Is this your first summit?
Yes, it is. Thanks so much.
Well, fantastic.
Pleasure.
Well, it's great to have you here. I hope you have a chance to engage and share some of your ideas and enjoy the week.
Sure. Thank you so much.
Thank you. Congratulations. Nehas mentioned that she first got interest in open source at university, and it made me think, Red Hat's recently started our Red Hat Academy program that looks to programmatically infuse Red Hat technologies in universities around the world. It's exploded in a way we had no idea. It's grown just incredibly rapidly, which I think shows the interest that there really is in open source and working in an open way at universities. So it's really a phenomenal program. I'm also excited to announce that we're launching our newest open source story this year at Summit. It's called The Science of Collective Discovery, and it looks at what happens when communities use open hardware to monitor the environment around them and really how they can make impactful change based on that technologies. The world premiere of that will be at 5:15 on Wednesday at Moscone West. And so please join us for a drink, and we'll also have a number of the experts featured in that, and you can have a conversation with them as well. So with that, let's officially start the show.
Please welcome Red Hat President of Products and Technology, Paul Cormier.
Wow, good morning. I say it every year. I'm going to say it again. I know I repeat myself. It's just amazing. We are so proud here to be here today to wow you all week on how far we've come with open source and with the products that we provide at Red Hat. So welcome, and I hope the pride shows through. So, I told you 7 summits ago on this stage that the future would be open. And here we are, just 7 years later. This is the 14th summit, but just 7 years later after that, and much has happened. And I think you'll see today and this week that that prediction that the world would be open was a pretty safe prediction. But I want to take you just back a little bit to see how we started here. And it's not just how Red Hat started here. This is open source and Linux-based computing is now an industry norm. And I think that's what you'll see and hear this week. You know, we talked back then, 7 years ago, on our prediction about the Unix era and how hardware innovation with x86 was really the first step in a new era of open innovation. You know, companies like Sun, DEC, IBM, and HP, they really changed the world, the computing industry, with their Unix models. That was really the rise of computing. But I think what we really saw then was that single company innovation could only scale so far, could really get so far with that. These companies were very, very innovative, but they coupled hardware innovation with software innovation. And as one company, they could only solve so many problems. And even, which even complicated things more, they could only hire so many people in each of their companies. Intel came on the scene back then as the new independent hardware player. And you know, that was really the beginning of the drive for horizontal computing power and computing. This opened up a brand new vehicle for hardware innovation. A new hardware ecosystem was built around this common hardware base. Shortly after that, Stallman and Linus, they had a vision of an open model that was created, and they created Linux, but it was built around Intel. This was really the beginning of having a software-based platform that could also drive innovation. This kind of was the beginning of the changing of the world here. That system-level innovation, now having a hardware platform that was ubiquitous and a software platform that was open and ubiquitous, it really changed this system-level innovation. And that continues to thrive today. It was only possible because it was open. This could not have happened in a closed environment. It allowed the best ideas from anywhere, from all over, to come in and win, only because it was the best idea. That's what drove the rate of innovation at the pace you're seeing today, and which has never been seen before. We at Red Hat, we saw the need to bring this innovation to solve real-world problems in the enterprise. And I think that's going to be the theme of the show today. You're going to see us with our customers and partners talking about and showing you some of those real-world problems that we are solving with this open innovation. We created RHEL back then for this, for the enterprise. It was successful because it scaled, it was secure, and it was enterprise ready. It once again changed the industry, but this time through open innovation. This gave the hardware ecosystem a software platform. This open software platform gave the hardware ecosystem a software platform to build around. It unleashed them, the hardware side, to compete and thrive. It enabled innovation from the OEMs. New players building cheaper, faster servers. Even new architectures from ARM to Power sprung up. With this change, we have seen an incredible amount of hardware innovation over the last 15 years. That same innovation happened on the software side. We saw powerful implementations of bare metal Linux distributions out in the market. In fact, at one point there were over 300 distributions out in the market. On the foundation of Linux, powerful open source equivalents were even developed in every area of technology. Databases, middleware, messaging, containers, anything you could imagine, innovation just exploded around the Linux platform. Innovation at the core also drove virtualization. Both Linux and virtualization led to another area of innovation, which you're hearing a lot about now, public cloud. This innovation started to proceed at a rate that we had never seen before. We had never experienced this in the past. In this unprecedented speed of innovation in software, was now possible because you didn't need a chip foundry in order to innovate. You just needed great ideas in the open platform that was out there. Customers seeing this innovation in the public cloud sparked their desire to build their own Linux-based cloud platforms. And customers are now bringing that cloud efficiency on-premise in their own data centers. Public clouds demonstrated so much efficiency that data centers and architects wanted to take advantage of it on-premise, within their own controlled environments. This really allowed companies to make the most of existing investments, from data centers to hardware. They also gained many new advantages, from data sovereignty to new, flexible, agile approaches. I want to bring Burr and his team up here to take a look at what building out an on-premise cloud can look like today. Burr, take it away.
I am super excited to be with all of you here at Red Hat Summit. I know we have some amazing things to show you throughout the week, but before we dive into this demonstration, I want you to take just a few seconds, just a quick moment to think about that really important event in your life, that moment you turned on your first computer. Maybe it was a TRS-80, a Sinclair, an Atari. I even had an AT&T 3B2 at one point. But in my specific case, I was sitting in a classroom in Hawaii, and I could see all the way from Diamond Head to Pearl Harbor, so just keep that in mind. And I turned on an IBM PC with dual floppies, and I remember issuing my first commands, writing my first little bit of code, and I was totally hooked. It was like a magical moment. And I've been hooked on computers for the last 30 years. So I want you to hold that image in your mind for just a moment, just a second, while we show you the computers we have here on stage. Let me turn this over to Jay Ferrandini, who's our worldwide DevOps manager, and he's going to show us his hardware. What do you got, Jay?
Thank you, Burr. Good morning, everyone, and welcome to Red Hat Summit. We have so many cool things to show you this week. I am so happy to be here, and my favorite thing about Red Hat Summit is we're allowed to kind of share all of our stories, much like Burr just did. We also love to talk about the hardware and the technology that we brought with us. In fact, it's become a bit of a competition. So this year we said, let's win this thing, and I think we might have won. We brought a cloud with us. So right now, this is a private cloud. Throughout the course of the week, we're going to turn this into a very, very interesting open hybrid cloud right before your eyes. So everything you see here will be real and happening right on this thing right behind me here. So thanks to our 4 incredible partners, IBM, Dell, HP, and Supermicro, we've built a very vendor heterogeneous cloud here. Extra special thanks to IBM, because they loaned us a Power 9 machine, so now we actually have multiple architectures in this cloud. So as you know, one of the greatest benefits to running Red Hat technology is that we run on just about everything. And I can't stress enough how powerful that is, how cost-effective that is, and it just makes my life easier, to be honest. So if you're interested, the people that built this actual rack right here are going to be hanging out in the customer success zone this whole week. It's on the 2nd floor of the lobby there, and they'd be glad to show you exactly how they built this thing. So let me show you what we actually have in this rack. So contained in this rack, we have 1,056 physical cores right here. We have 5.5 terabytes of RAM, and just in case, we threw 50 terabytes of storage in this thing. So, Burr, that's about 2 million times more powerful than that first machine you booted up. Thanks to APC, we're actually capable of putting all the power needs and cooling right in this rack. So there's your data center right there. It occurred to me last night that I could actually pull the power cord on this thing and kick it up a notch. We could have the world's first mobile portable hybrid cloud. So I'm going to go ahead and unplug this.
No, seriously, let's not unplug the thing. We got it working now.
Well, Burr gets a little nervous, but next year we're rolling this thing around, okay?
Okay.
So to recap, multiple vendors, check. Multiple architectures, check. Multiple public clouds plugged right into this thing, check. And everything, everywhere, is running the same software from Red Hat. So that is a giant check. So Burr and Angus, why don't we get the demos rolling?
Awesome. So we have some amazing hardware, amazing computers on the stage, but now we need to light it up. And we have Angus Thomas, who represents our OpenStack engineering team, and he's going to show us what we can do with this awesome hardware. Angus?
Thank you, Burr. So, this is an impressive rack of hardware that Jay has brought up on the stage. What I want to talk about today is putting it to work. With OpenStack Platform Director, we're going to turn it from a lot of potential into a flexible, scalable private cloud. We've been using Director for a while now to take care of managing hardware and orchestrating the deployment of OpenStack. What's new is that we're bringing the same capabilities for on-premise management to the deployment of OpenShift. Director deploying OpenShift in this way is the best of both worlds. It's bare metal performance, but with an underlying infrastructure as a service that can take care of deploying in new instances and scaling out, and a lot of the things that we expect from a cloud provider. Director is running on a virtual machine on Red Hat virtualization at the top of the rack, and it's going to bring everything else under control. What you can see on the screen right now is the Director UI, and as you see, some of the hardware in the rack is already being managed. At the top level, we have information about the number of cores and the amount of RAM and the disks that each machine have. If we dig in a bit, there's information about MAC addresses and IPs and the management interface, the BIOS, and the kernel version. Dig a little deeper, and there is information about the hard disks. All of this is important because we want to be able to make sure that we're putting workloads exactly where we want them. Jay, could you please power on the two new machines at the top of the rack?
Sure.
All right, thank you. So when those two machines come up on the network, Director is going to see them, see that they're new and not already under management, and is immediately going to go into the hardware inspection that populates this database and gets them ready for use. So we also have profiles, which you can see here. Profiles are the way that we match the hardware in a machine to the kind of workload that it's suited to. This is how we make sure that machines that have all the disks run Ceph, and machines that have all the RAM run our application workloads, for example. There's two ways these can be set. When you're dealing with a rack like this, you can go in and individually tag each machine. But Director scales up to data centers. So we have a rules matching engine, which will automatically take the hardware profile of a new machine and make sure it gets tagged in exactly the right way. So we can automatically discover new machines on the network, and we can automatically match them to a profile. That's how we streamline and scale up operations. Now, I want to talk about deploying the software. We have a set of validations. We've learned over time about the misconfigurations in the underlying infrastructure which can cause the deployment of a multi-node distributed application like OpenStack or OpenShift to fail. If you have the wrong VLAN tags on a switch port, or DHCP isn't running where it should be, for example, you can get into a situation which is really hard to debug. A lot of our validations actually run before the deployment. They look at what you're intending to deploy, and they check that the environment is the way that it should be. And they'll preempt problems. And obviously, preemption is a lot better than debugging. Something new that you probably have not seen before is Director managing multiple deployments of different things side by side. Before we came out on stage, we also deployed OpenStack on this rack. Just to keep me honest, let me jump over to OpenStack very quickly. A lot of our OpenStack customers will be familiar with this UI. And the bare metal deployment of OpenStack on our rack is actually running a set of virtual machines, which is running Gluster. You're going to see that put to work later on during the summit. Jay's gone to an awful lot of effort to get this hardware up on the stage, so we're going to use it as many different ways as we can. OK, let's deploy OpenShift. If I switch over to the deployment plan view, there's a few steps. First thing you need to do is make sure we have the hardware. I already talked about how Director manages hardware. It's smart enough to make sure that it's not going to attempt to deploy onto machines that are already in use. It's only going to deploy on machines that have the right profile. But I think with the rack that we have here, we've got enough. Next thing is deployment configuration. This is where you get to customize exactly what's going to be deployed to make sure that it really matches your environment. If there are external IPs for additional services, you can set them here. Whatever it takes to make sure that the deployment is going to work for you. As you can see on the screen, we have a set of options around enabling TLS for encryption network traffic. If I dig a little deeper, there are options around enabling IPv6 and network isolation so that different classes of traffic go over different physical NICs. Okay, then we have roles. Now roles, this is essentially about the software that's going to be put on each machine. Director comes with a set of roles for a lot of the software that Red Hat supports, and you can just use those, or you can modify them a little bit if you need to add a monitoring agent or whatever it might be, or you can create your own custom roles. Director has quite a rich syntax for custom role definition and custom network topologies, whatever it is you need in order to make it work in your environment. So the roles that we have right now are going to give us a working instance of OpenShift. If I go ahead and click through, the validations are all looking green. So right now, I can click the button, start to the deploy, and you will see things lighting up on the rack. Director's going to use IPMI to reboot the machines, provision them with a RHEL image, put the containers on them, and start up the application stack. OK, so one last thing. Once the deployment is done, you're going to want to keep Director around. Director has a lot of capabilities around what we call day 2 operational management, bringing in new hardware, scaling out deployments, dealing with updates, and critically dealing with upgrades as well. So, having said all of that, it is time for me to switch over to an instance of OpenShift deployed by Director, running on bare metal on our rack, and I need to hand this over to our developer team so they can show what they can do with it. Thank you.
That is so awesome, Angus. So what you've seen now is going from bare metal to the ultimate private cloud with OpenStack Director, making OpenShift ready for our developers to build their next generation applications. Thank you so much, guys. That was totally awesome. I love what you guys showed there. Now I have the honor of introducing a very special guest, one of our earliest OpenShift customers who understands the necessity of the private cloud inside their organization, and more importantly, they're fundamentally redefining their industry. Please extend a warm welcome to Dietmar Fosser from Amadeus.
Well, good morning, everyone. A big thank you for having Amadeus here and myself. So, as it was just said, Amadeus, well, first of all, we are a large IT provider in the travel industry, so serving essentially airlines, hotel chains, distributors like Expedia and others. We started very early with OpenShift, like a bit more than 3 years ago, and we jumped on it when Red Hat teamed with Google to bring in Kubernetes into this. So let me quickly share a few figures about Amadeus to give you like a sense of what we are doing and the scale of our operations. So some of our key KPIs. One of our key metrics is what we call passenger boarded. So that's the number of customers that physically board a plane over the year. So through our systems, it's roughly 1.6 billion people checking in, taking aircraft under the Amadeus systems, close to 600 million travel agency bookings. Virtually all airlines are on the system, and one figure I want to stress out a little bit is this 1 trillion availability requests per day. That's when I read this figure, my mind boggles a little bit. This means in continuous throughput, more than 10 million hits per second. So of course, these are not traditional database transactions. It's highly cached in memory, and these applications are running over like more than 100,000 cores. So it's really big stuff. So today, I want to give some concrete feedback what we are doing. So I have chosen 2 applications, products of Amadeus that are currently running on production in different hosting environments, as the theme here is of this talk, hybrid cloud. So I want to give some concrete feedback of how we architect the applications. And of course, it stays relatively high level. So here, I have taken one of our applications that is used in the hospitality environment. So we have built this for a very large US hotel chain, and it's currently in full swing brought into production. So like 30% of the global 5,000 plus hotels are on this platform now. So here you can see that we use as a pass, of course, OpenShift. That's the most central piece of our hybrid cloud strategy. On the database side, we use Oracle and Couchbase. Couchbase is used for the heavy-duty, fast access, more key-value store, but also to replicate data across 2 data centers. In this case, it's running over 2 US-based data centers, East and West Coast topology, that are fit, so run by Amadeus, that are fit with VMware for the virtualization, OpenStack on top of it, and then OpenShift to host and welcome the applications. On the right-hand side, you see the kind of tools, if you want to call them tools, that we use. These are the principal ones. Of course, the real picture is much more complex. But in essence, we use Terraform to map to the APIs of the underlying infrastructure. So obviously there are differences when you run on OpenStack or the Google Compute Engine or AWS, Azure. So some tweaking is needed. We use Red Hat Ansible a lot. We also use Puppet. So you can see these are really the big pieces of this installation. And if we look to the topology, again, very high level. So these 2 locations basically map the data centers of our customers. So they are in close proximity because the response time and the SLAs of this application are very tight. So that's an example of an application that is architectured mostly with high availability in mind, not necessarily full global worldwide scaling, but of course it could be scaled. But here the idea is that we can swing from one data center to the other in matters of minutes. Both take traffic, data is fully synchronized across those data centers, and well, the switch back and forth is very fast. The second example I have taken is what we call the shopping box. This is when people go to Kayak or Expedia and they get inspired where they want to travel to. This is really the piece that shoots most of the transactions into Amadeus. So we architect here more for high scalability. Of course, availability is also a key. But here, scaling and geographical spread is very important. So in short, it runs partially on-premise in our Amadeus data center, again on OpenStack. And we deploy it mostly in the first step on the Google Compute Engine, and currently, as we speak, on Amazon, on AWS. And we work also together with Red Hat to qualify the whole show on Microsoft Azure. Here in this application, it's the same building blocks. There is a large streaming aspect to it. So we bring Kafka into this, working with Red Hat and another partner to bring Kafka under OpenShift, because at the end, we want to use OpenShift to administrate the whole show. So over time, also databases. And the topology here, when you look to the physical deployment topology, while it's very classical, we use the regions and the availability zone concept. So this application is spread over 3 principal continental regions. And so it's a high-level view with different availability zones. And in each of those availability zones, we take a hit of several 10,000 transactions. So that was it really in very short, just to give you a glimpse on how we implement hybrid clouds. I think that's the way forward. It gives us a lot of freedom, and it allows us to discuss in a much more educated way with our customers that sometimes have already deals in place with one cloud provider or another. So for us, it's a lot of value to leave them the choice, basically. Voilà, that was a very quick overview of what we are doing. We're together with Red Hat based on OpenShift essentially here, and more OpenStack coming into the picture. Hope you found this interesting. Thanks a lot, and have a nice summit.
Thank you so much, Dietmar. Thanks. Great solution. We've worked with Dietmar and his team for a long time. Great solution. So I want to take us back a little bit. I want to circle back. I sort of ended talking a little bit about the public cloud. So let's circle back there. You know, even though some applications need to run in various footprints on premise, there's still great gains to be had for running certain applications in the public cloud. I mean, public cloud will be as impactful to the industry as Unix era of computing was. But by itself, it'll have some of the same limitations and challenges that model had. Today, there's tremendous cloud innovation happening in the public cloud. It's being driven by a handful of massive companies. And much like the innovation that Sun, DEC, HP, and others drove in the Unix era of computing, many customers want to take advantage of the best innovation, no matter where it comes from. But as they even eventually saw in the Unix era, they can't afford the best innovation at the cost of a siloed operating environment. With the open community, we are building a hybrid application platform that can give you access to the best innovation, no matter which vendor or which cloud that it comes from. Letting public cloud providers innovate in services beyond what customers or any one provider can do on their own, such as large-scale learning, machine learning, or artificial intelligence, built on the data that's unique probably to that one cloud, but consumed in a common way for the end customer across all applications in any environment on any footprint in their overall IT infrastructure. This is exactly what RHEL brought to our customers in the Unix era of computing, that consistency across any of those footprints. Obviously, enterprises will have applications for all different uses. Some will live on-premise, some in the cloud. Hybrid cloud is the only practical way forward. I think you've been hearing that from us for a long time. It is the only practical way forward, and it'll be as impactful as anything we've ever seen before. I want to bring Burr and his team back to see a hybrid cloud deployment in action. Burr?
All right, earlier you saw what we did with taking bare metal and lighting it up with OpenStack Director and making it OpenShift, ready for developers to build their next generation applications. Now we want to show you one of those next generation applications. And what we've done is we've taken OpenShift and spread it out and installed it across Azure and Amazon, a true hybrid cloud. So with me on stage today is Ted, who's going to walk us through an application, and Brent Midwood, who's our DevOps engineer, who's going to make sure he's monitoring on the backside that we make sure we do a good job. So at this point, Ted, what have you got for us?
Thank you, Burr, and good morning, everybody. This morning, we're running on the stage in our private cloud an application that's providing fraud detection service for financial transactions. And our customer base is rather large, and we occasionally take extended bursts of traffic, of heavy traffic load. So in order to keep our latency down and keep our customers happy, we've deployed extra service capacity in the public cloud. So we have capacity with Microsoft Azure in Texas and with Amazon Web Services in Ohio. So we use OpenShift Container Platform on all three locations because OpenShift makes it easy for us to deploy our containerized services wherever we want to put them. But the question still remains, how do we establish seamless communication across our entire enterprise? And more importantly, how do we balance the workload across these three locations in such a way that we efficiently use our resources and that we give our customers the best possible experience? So this is where Red Hat AMQ Interconnect comes in. As you can see, we've deployed AMQ Interconnect alongside our fraud detection application in all three locations. And if I switch to the AMQ console, we'll see the topology of the network that we've created here. So the router inside the onstage here has made connections outbound to the public routers in AWS and Azure. These connections are secured using mutual TLS authentication and encryption. And once these connections are established, AMQ figures out the best way automatically to route traffic to where it needs to get to. So what we have right now is a distributed, reliable, brokerless message bus that expands our entire enterprise. Now, if you want to learn more about this, make sure that you catch the AMQ breakout tomorrow at 11:45 with Jack Britton and David Ingham. Let's have a look at the message flow. And we'll dive in and isolate the fraud detection API that we're interested in. And what we see is that all the traffic is being handled in the private cloud. That's what we expect because our latencies are low and they're acceptable. But now if we take a little bit of a burst of increased traffic, we're going to see that AMQ is going to push a little of that traffic out onto the public cloud. So Azure's picking up some of the load now to keep the latencies down. Now when that subsides, Azure finishes up what it's doing and goes back offline. Now if we take a much bigger load increase, you'll see two things. First of all, Azure is going to take a bigger proportion than it did before, and Amazon Web Services is going to get thrown into the fray as well. Now, AWS is actually doing less work than I expected it to do. I expected a little bit bigger of a slice there. But this is an interesting illustration of what's going on for load balancing. AMQ load balancing is sending requests to the services that have the lowest backlog in order to keep the latencies as steady as possible. So AWS is probably running slowly for some reason, and that's causing AMQ to push less traffic its way. Now, the other thing you're going to notice is, if you look carefully, this graph fluctuates slightly, and those fluctuations are caused by all the variances in the network. We have the cloud on stage, and we have the clouds in the various places across the country. There's a lot of equipment, there's a lot of layers of virtualization and networking in between, and we're reacting in real time to the reality on the digital street. So, Burr, what's the story with AWS?
I noticed there's a problem right here, right now. We seem to have a little bit of a performance issue.
Yeah.
So guys, I noticed that as well, and a little bit ago I actually got an alert from Red Hat Insights letting us know that there might be some potential optimizations we could make to our environment.
Okay.
So let's take a quick look at Insights. So here's the Red Hat Insights interface. You can see our 3 OpenShift deployments. So we have the setup here on stage in San Francisco, we have our Azure deployment in Texas, and we also have our AWS deployment in Ohio. And Insights is highlighting that that deployment in Ohio may have some issues that need some attention. So Red Hat Insights collects anonymized data from managed systems across our customer environment, and that gives us visibility into things like vulnerabilities, compliance, configuration assessment, and of course Red Hat subscription consumption. All of this is presented in a SaaS offering, so it's really, really easy to use. It requires minimal infrastructure up front, and it provides an immediate return on investment. What Insights is showing us here is that we have some potential issues on the configuration side that may need some attention. From this view, I actually get a look at all the systems in our inventory, including instances and containers, and you can see here on the left that Insights is highlighting one of those instances as needing some potential attention. It might be a candidate for optimization. This might be related to the issues that you were seeing just a minute ago. Insights uses machine learning and AI techniques to analyze all collected data. So we combine collected data from not only this system's configuration, but also with other systems from across the Red Hat customer base. This allows us to compare ourselves to how we're doing across the entire set of industries, including our own vertical, in this case, the financial services industry, and we can compare ourselves to other customers. We also get access to tailored recommendations that let us know what we can do to optimize our systems. So in this particular case, we're actually detecting an issue here where we are an outlier. So our configuration has been compared to other configurations across the customer base, and in this particular instance, in this security group, we're misconfigured. And so Insights actually gives us the steps that we need to use to remediate the situation, and the really neat thing here is that we actually get access to a custom Ansible playbook. So if we want to automate that type of a remediation, we can use this inside of Red Hat Ansible Tower, Red Hat Satellite, Red Hat Cloud Forms. It's really, really powerful. The other thing here is that we can actually apply these recommendations right from within the Red Hat Insights interface. So with just a few clicks, I can select all the recommendations that Insights is making, and using that built-in Ansible automation, I can apply those recommendations really, really quickly across a variety of systems. This type of intelligent automation is really cool. It's really fast and powerful. So really quickly here, we're going to see the impact of those changes, and so we can tell that we're doing a little better than we were a few minutes ago when compared across the customer base as well as within the financial industry. And if we go back and look at the map, we should see that our AWS deployment in Ohio is in a much better state than it was just a few minutes ago. So I'm wondering, Ted, if this had any effect and might be helping with some of the issues that you were seeing.
Oh, let's take a look.
Looks like it went green. Now let's see what it looks like over here.
Yeah. So it doesn't look like the configuration has taken effect quite yet. Maybe there's some delay.
Little moment. There it goes.
Okay.
Awesome. Fantastic.
Brent is the man.
Yeah. So now we're load balancing across the 3 clouds.
Very nice.
Fantastic. Well, I have to admit, Ted, I truly love how we can route requests and dynamically load transactions across these 3 clouds. A truly hybrid cloud-native application you guys saw here on stage for the first time, and it's a fully portable application. If you build your applications with OpenShift, you can move it from cloud to cloud to cloud, on stage private, all the way out to the public. So that is totally awesome. We also have the application being fully managed by Red Hat Insights. I love having that intelligence watching over us and ensuring that we're doing everything correctly. That is fundamentally awesome. Thank you so much for that.
You know, there's these real-world insight into how our products and technologies are really running the businesses today. That's just the most exciting part. So thanks again, Marty. Even with as much progress as you've seen demonstrated here, and you're going to continue to see all week long, we're far from done. So I want to just take us a little bit into the path forward and where we go today. We've talked about this a lot. Innovation today is driven by open source development. I don't think there's any question about that, certainly not in this room, and even across the industry as a whole. That's a long way that we've come from when we started our first summit 14 years ago. With over 1 million open source projects out there, this innovation aggregates into various community platforms, and it finally culminates in commercial open source developed products. These products run many of the mission-critical applications in business today. You've heard just a couple of those today here on stage, but it's everywhere. It's running the world today. But to make customers successful with that innovation to run their real-world business applications, these open source products have to be able to leverage increasingly complex infrastructure footprints. We must also ensure a common base for the developer and ultimately the application, no matter which footprint they choose. As you heard Marty say, the developers want choice here. No matter which footprint they are ultimately going to run those applications on, they want that flexibility, from the data center to possibly any public cloud out there. And regardless of whether that application was built yesterday or has been running the business for the last 10 years and was built on 10-year-old technology. This is the flexibility that developers require today. But with this different infrastructure, we may require different pieces of the technical stack in that deployment. One example of this, it affects many things, is KVM, which provides the foundation for many of those use cases that require virtualization. KVM offers a level of consistency from a technical perspective, but RHEL extends that consistency to add a level of commercial and ecosystem consistency for the application across all those footprints. This is very important in the enterprise. But while RHEL and KVM form the foundation, other technologies are needed to really satisfy the functions on these different footprints. Traditional virtualization has requirements that are satisfied by projects like Overt and products like Rev. Traditional private cloud implementations has requirements that are satisfied on projects like OpenStack and products like Red Hat OpenStack Platform. And as applications begin to become more container-based, we are seeing many requirements driven natively into containers. The same Linux in different forms provides this common base across these 4 footprints. This level of compatibility is critical to operators who must best utilize, secure, and deploy the infrastructure that they have and they're responsible for. Developers, on the other hand, they care most about having a platform that creates that consistency for their applications. They care about their services and the services that they need to consume within those applications, and they don't want limitations on where they run. They want serverless, but they want it anywhere, not necessarily just from Amazon. They want integration between applications, no matter where they run. They still want to run their Java EE, now named Jakarta EE, apps and bring those applications forward into containers and microservices. They need to be able to orchestrate these frameworks and many more across all these different footprints in a consistent, secure fashion. This creates natural tension between development and operations. Frankly, customers amplify this tension with organizational boundaries that are holdover from the Unix era of computing. It's really the job of our platforms to seamlessly remove these boundaries, and it's the goal of Red Hat to seamlessly get you from the old world to the new world. We're going to show you a really cool demonstration now. We're going to show you how you can automate this transition. First, we're going to take a Windows virtual machine from a traditional VMware deployment. We're going to convert it into a KVM-based virtual machine running in a container, all under the Kubernetes umbrella. This makes virtual machines more accessible to the developer. This will accelerate the transformation of those virtual machines into cloud-native, container-based form. We will work this capability over the product line in the coming releases so we can strike the balance of enabling our developers to move in this direction. We want to be able to do this while enabling mission-critical operations to still do their job. So let's bring Burr and his team back up to show you this in action. Burr, one more. Thanks.
All right. Well, at Red Hat, we recognize that large organizations, large enterprises, have a substantial investment in legacy virtualization technology. And this is holding you back. You have thousands of virtual machines that need to be modernized. So what you're about to see next, okay, is something very special. With me here on stage, we have James Lebowski. He's going to be walking us through, he represents our operations folks, and he's going to be walking us through a mass migration. But also is Itamar Haim, who's our lead developer of a very special application, and he's going to be modernizing, containerizing, and optimizing our application. All right, so let's get started. James?
Thanks, Burr. Yeah, so as you can see, I have a typical VMware environment here. I'm in the vSphere client. I've got a number of virtual machines, a handful of them that make up one of my applications for my development environment in this case. And what I want to do is migrate those over to a KVM-based Red Hat virtualization environment. So what I'm going to do is I'm going to go to CloudForms, our cloud management platform. That's our first step. And you know CloudForms actually already has discovered both my Rev environment and my vSphere environment and understands the compute, network, and storage there. So you'll notice one of the capabilities we've built is this new capability called migrations. And underneath here, I could begin to, there's two steps I need to do. The first thing I need to do is start to create my infrastructure mappings. What this will allow me to do is map my compute, network, and storage between vSphere and Rev, so CloudForms understands how those relate. So let's go ahead and create an infrastructure mapping. We'll call that Summit Infrastructure Mapping. And then I'm going to begin to map my two environments. First, the compute, so the clusters here. Next, the data stores. So those virtual machines happen to live on data store 2 in vSphere, and I'll target them at data 2 inside of my Rev environment. And finally, my networks. Those live on network 100, so I'll map those from vSphere to Rev. So once my infrastructure is mapped, the next step I need to do is actually begin to create a plan to migrate those virtual machines. So I'll continue to the plan wizard here. I'll select the infrastructure mapping I just created, and I'll select migrate my development environment for those virtual machines to Rev. And then I need to import a CSV file. This CSV file is going to contain a list of all the virtual machines that I want to migrate that were there. And that's it. Once I hit create, what's going to happen is CloudForms is going to begin in an automated fashion, shutting down those virtual machines, begin converting them, taking care of all the minutia that you'd have to do manually. It's going to do that all automatically for me, so I don't have to worry about all those manual interactions. And no longer do I have to go manually shut them down, but it's going to take care of that all for me. So you can see the migration's kicked off here. I've got my VMs are migrating here, and if I go back to the screen here, you can see that we're going to start seeing those shut down.
Okay, awesome. But if people want to know more information about this, how would they dive deeper into this technology later this week?
Yeah, it's a great question. So we have a workload portability session in the hybrid cloud on Wednesday if you want to see a presentation that deep dives into this topic and how some of the methodologies to migrate. And then on Thursday, we actually have a hands-on lab. It's the IT optimization VM migration lab that you can check out. And as you can see, those are shutting down here.
Yeah, we see it powering off right now. That's fantastic.
Absolutely. So if I go back, now that's going to take a while. You got to convert all the disks and move them over. But what you'll notice is previously I had already run one migration of a single application that was a Windows virtual machine running. And if I browse over to Red Hat Virtualization, I can see on the dashboard here, I can browse to virtual machines. I have migrated that Windows virtual machine. And if I open up a tab, I can now browse to my Windows virtual machine, which is running our Wingtip Toy Store application, our sample application here. And now my VM has been moved over from from VMware to Rev and is available for Itamar.
All right, available to our developers. Yep. All right, Itamar, what are you going to do for us here?
Well, James, it's great that you can save costs by moving from VMware to Red Hat Virtualization. But I want to containerize our application, and with container-native virtualization, I can run my virtual machine on OpenShift like any other container using KubeVirt, a Kubernetes operator, to run and manage virtual machines. Let's look at the OpenShift Service Catalog. We can see we have a new virtualization section here. We can import KVM or VMware virtual machines, or if they are already loaded, we can create new instances of them for the developer to work with. Just need to give name, CPU, memory. We can do other virtualization parameters and create our virtual machines. Now let's see how this looks like in the OpenShift console. The cool thing about KVM is virtual machines are just Linux processes, so they can act and behave like other OpenShift applications. We built on more than a decade of virtualization experience with KVM, Red Hat virtualization, and OpenStack, and can now benefit from Kubernetes and OpenShift to manage and orchestrate our virtual machines. Since we know this virtual machine, this container is actually a virtual machine, we can do virtual machine stuff with it, like shutdown, reboot, or open a remote desktop session to it. But we can also see this is just a container like any other container in OpenShift. And even though the web application is running inside a Windows virtual machine, the developer can still use OpenShift mechanisms like services and routes. Let's browse our web application using the OpenShift service. It's the same Wingtip Toys application, but this time the virtual machine is running on OpenShift. But we're not done. We want to containerize our application. Since it's a Windows virtual machine, we can open a remote desktop session to it. We see we have here Visual Studio and an ASP.NET application. Let's start containerizing by moving the Microsoft SQL Server database from running inside the Windows virtual machine to running on Red Hat Enterprise Linux as an OpenShift container. We'll go back to the OpenShift service catalog. This time we'll go to the database section, and just as easily we'll create a SQL Server container. Just need to accept the EULA, provide password, choose the edition we want, and create a database. And again, we can see the SQL Server is just another container running on OpenShift. Now let's find the connection details for our database. To keep this simple, we'll take the IP address of our database service, go back to the web application, to Visual Studio, update the IP address in the connection string, publish our application, and go back to browse it through OpenShift. Fortunately for us, the user experience team heard we're modernizing our application, so they pitched in and pushed new icons to use with our containerized database to also modernize the look and feel. It's still the same Wingtip Toys application. It's running in a virtual machine on OpenShift, but it's now using a containerized database. To recap, we saw that we can run virtual machines natively on OpenShift like any other container-based application, modernize and mesh them together. We containerize the database, but we can use the same approach to containerize any part of our application.
So there are some items here to deserve repeating. One thing you saw is Red Hat Enterprise Linux running SQL Server in a container on OpenShift. And you also saw Windows VM with a .NET native application also running inside of OpenShift. So tell us what's special about that. That seems pretty crazy what you did there.
Exactly, Burr. If we take a look under the hood, we can use the Kubernetes commands to see the list of our containers. In this case, the SQL Server and the virtual machine containers. But since KubeVirt is a Kubernetes operator, we can actually use Kubernetes commands like kubectl to list our virtual machines and manage our virtual machines like any other entity in Kubernetes.
Oh, I love that. So there's your Kubernetes YAML. We can see the kind says virtual machine. That is totally awesome. Now, people here are going to be very excited about what they just saw. Where can they get more information, and when will this be coming? What can they do to dive in?
This will be available as part of Red Hat Cloud Suite in Tech Preview later this year. But we are looking for early adopters now, so give us a call. Also, come check our deep dive session introducing container native virtualization Thursday, 2 p.m.
Awesome, that is so incredible. So we went from the old to the new, from the closed to the open, the Red Hat way. You're going to be seeing more from our demonstration team this coming Thursday at 8 a.m. Do not be late. If you like what you saw today, you're going to see a lot more of that going forward. So we got some really special things in store for you. So at this point, thank you so much, Intamar. Thank you so much. You guys were awesome. Yeah? Now we have one more special guest, a very early adopter of Red Hat Enterprise Linux. We've had over a 12-year partnership and relationship with this organization. They've been a steadfast Linux and middleware customer for many, many years now. Please extend a warm welcome to Raj Chana from the Royal Bank of Canada. Thank you.
Thank you. It's great to be here. RBC is a large global full services bank. We are the largest bank in Canada, top 10 global, operate in 30 countries, and run 5 key business segments: personal and commercial banking, investor and treasury services, capital markets, wealth management, and insurance. But honestly, unless you're in the banking segment, those 5 business segments that I just mentioned may not mean a lot to you. But what you might appreciate is the fact that we've been around in business for over 150 years. We started our digital transformation journey about 4 years ago. And we are focused on new and innovative technologies that will help deliver the capabilities and lifestyle our clients are looking for. We have a very simple vision, and we often refer to it as the digitally enabled bank of the future. But as you can appreciate, transforming a 150-year-old bank is not easy. It certainly does not happen overnight. To that end, we've had a clear, unwavering vision, a very strong innovation agenda, and most importantly, a focus towards a flawless execution. Today, in banking, business strategy and IT strategy are one and the same. They're not two separate things. We believe that in order to be the #1 bank, we have to have the #1 tech team. There is no question that most of today's innovations happens in the open source community. RBC relies on Red Hat as a key partner to help us consume these open source innovations in a manner that it meets our enterprise needs. RBC was an early adopter of Linux. We operate one of the largest footprints of RHEL in Canada. Same with JBoss. We've had tremendous success in driving cost out of infrastructure by partnering with Red Hat, while at the same time delivering a world-class hosting service to our business. Over our 12-year partnership, Red Hat has proven that they have mastered the art of working closely with the upstream open source community, understanding the needs of an enterprise like us, and delivering these open source innovations in a manner that we can consume and build upon. We are working with Red Hat to help increase our agility and better leverage public and private cloud offerings. We've adopted virtualization, Ansible, and containers, and are excited about continuing our partnership with Red Hat in this journey. Throughout this journey, we simply cannot replace everything we've had from the past. We have to bring forward these investments of the past and improve upon them with new and emerging technologies. It is about utilizing emerging technologies, but at the same time focusing on the business outcome. The business outcome for us is serving our clients and delivering the information that they're looking for whenever they need it and in whatever form factor they're looking for. But technology improvements alone are simply not sufficient to do a digital transformation. Creating the right culture of change and adopting new methodologies is key. We introduced Agile and DevOps, which has boosted the number of Agile projects at RBC and increased the frequency at which we do new releases to our mobile app. As a matter of fact, these methodologies have enabled us to deliver apps over 20x faster than before. The other point around culture that I wanted to mention was we wanted to build an engineering culture. An engineering culture is one which rewards curiosity, trying new things, investing in new technologies, and being a leader, not necessarily a follower. Red Hat has been a critical partner in our journey to date as we adopt elements of open source culture and engineering culture. What you've seen today about Red Hat's focus on new technology innovations while never losing sight of helping you bring forward the investments you've already made in the past is something that makes Red Hat unique. We are excited to see Red Hat's investment and leadership in open source technologies to help bring the potential of these amazing things together. Thank you.
Thank you so much, Raj. Thanks. That's great. The thing, you know, seeing going from the old world to the new with automation. So, you know, the things you've seen demonstrated today, they're more sophisticated than any one company could ever have done on their own. Certainly not by using a proprietary development model. Because of this, it's really easy to see why open source has become the center of gravity for enterprise computing today. With all the progress open source has made, we're constantly looking for new ways of accelerating that into our products so we can take that into the enterprise with customers like these that you've met today. You know, we recently made an addition to the Red Hat family. We brought in CoreOS to the Red Hat family. And you know, adding CoreOS has really been our latest move to accelerate that innovation into our products. This will help the adoption of OpenShift Container Platform even deeper into the enterprise. And as we did with the Linux core platform in 2002, this is just exactly what we did with Linux back then. Today, we're announcing some exciting new technology directions. First, we'll integrate the benefits of automated operations. So for example, you'll see dramatic improvements in the automated intelligence about the state of your clusters in OpenShift with the CoreOS additions. Also, as part of OpenShift, we'll include a new variant of RHEL called Red Hat CoreOS, maintaining the consistency of RHEL for the operations side of the house while allowing for a consumption of over-the-air updates from the kernel to Kubernetes. Later today, you'll hear how we are extending automated operations beyond customers and even out to partners. All of this starting with the next release of OpenShift in July. Now, all of this, of course, will continue in an upstream, open source innovation model. That includes continuing Container Linux for the community users today, while also evolving the commercial products to bring that innovation out to the enterprise. This combination is really defining the platform of the future. Everything we've done for the last 16 years since we first brought RHEL to the commercial market has been to get us just to this point. Hybrid cloud computing is now being deployed multiple times in enterprises every single day, all powered by the open source model. And powered by the open source model, we will continue to redefine the software industry forever. You know, in 2002, with all of you, we made Linux the choice for enterprise computing. This changed the innovation model forever. And I started this session today talking about our prediction of 7 years ago on the future being open. We've all seen so much happen in those 7 years. We at Red Hat have celebrated our 25th anniversary, including 16 years of RHEL in the enterprise. It's now 2018. Open hybrid cloud is not only a reality, but it is the driving model in enterprise computing today. And this hybrid cloud world would not even be possible without Linux as a platform and the open source development model to build around it. And while we think we may have accomplished a lot in that time, and we may think we have changed the world a lot, we have. But I'm telling you, the best is yet to come now that Linux and open source software is firmly driving that innovation in the enterprise. What we've accomplished today and up till now has just set the stage for us together to change the world once again. And just as we did with RHEL more than 15 years ago, with our partners, we will make hybrid cloud the default in the enterprise. and I will take that bet every single day. Have a great show, and have fun watching the future of computing unfold right in front of your eyes. See you later.